Okay friends, so we'll discuss here now next part of this solution of linear differential equation, that is particular integral. Again we are knowing that if any general linear differential equation is given, this is f of d into y equal to this x, then this equation having solution as y equal to cf plus pi. Cf is complementary function, pi is particular integral, and this is our general solution. Till now we are knowing that how to find out this Cf. Now for Cf we are using auxiliary equation. This auxiliary equation is f of d equal to 0, and using roots of this auxiliary equation we can decide Cf. Here we are finding roots depending on condition of roots: real and distinct, real and repeated, and complex. Using that we can find out Cf. Now next part, to solve this solution, that is equation star, we have to discuss about this pi. Now how to find out pi? Again, one thing is that this Cf is depending on homogeneous part of this equation, and surely this pi is depending on right hand side of this linear differential equation. That means this x, pi is depending on x. Now here simple definition of this pi, we are finding this pi for this equation number 1. This is our linear differential equation 1. Its pi is 1 upon f of d into x. If we are finding this, then we are getting our pi. Now this d is an operator. We are knowing that this d is nothing but d by dx. Using this we can find out our pi. Now there are some methods to find out pi. In our syllabus there are 3 methods to find out pi. Number 1 is a general method. Second is method of variation of parameter, and third one method is, again, this is shortcut method. Now this shortcut method is somewhat easy method, therefore I will go through first of all shortcut method, and we will discuss how to find out pi by using shortcut method. Now in shortcut method, the shortcut method having some limitations. We are not using shortcut method for all examples, all problems. We are using shortcut method for problems whose this x means right hand side, this x is function of e raised to power x, sin x, or cos x. This is sin hyperbolic x or cos hyperbolic x, or sometimes this is for polynomial x raised to power m. You can use this for x into this v is the function of x. If our function containing this x containing e raised to x, sine function or cos function, this is trigonometric function. Now hyperbolic sine function or cos function, x raised to power m, this is polynomial, x into v, now v is the function of x, and e raised to power x into this v is function of x. If right side containing out of these, among these, then we can find pi by using shortcut method. But this is very simple method. Sometimes or usually we can find the Cf by using this method, and orally we are getting Cf under this method. Now we will discuss directly some results to find out pi as per this method. Now here I will take, this is our function, our general LDE is f of d into y equal to x, and our pi is our 1 upon f of d, this operating on x, this is our pi. Now I will take x as e raised to power x. Then our pi, if under this condition, our pi is 1 upon f of d into x. X is e raised to power x. This is our pi. Here directly you can find this pi as 1 upon f of a, means this operator d we are replacing by a, e raised to power x, and here is condition f of a is not equal to 0. If this happens, then we are getting this pi. Sometimes suppose this may happens there, 1 upon f of a e raised to x, and f of a is not equal to 0, but suppose sometime this may happens f of a equal to 0. Again, proof is very easy. I am not discussing about proof, directly I am giving formula. If f of a is not equal to 0, then in this case we can write f of its derivative, and again we are replacing d by a, e raised to power x. Moreover, f dash of a is not equal to 0. Again, suppose if this is equal to 0, then we can continue successively. This is 1 upon f its double prime, double derivative of this function e raised to x, f double dash of a is not equal to 0. And in this way we can continue. Again, suppose this is equal to 0, then we can write here 1 upon f its third derivative e raised to x, provided that this should be not equal to 0. Again, we can successively continuing this, we can write our this result. This is very easy. Particular integral for 1 upon f of d e raised to x is, we can replace this d by a. Means here again I will recall this as pi for 1 upon f of d into e raised to x is 1 upon f of a into e raised to x. Means we can replace this d by a. We have to replace this d by a, then we can write this pi. Suppose I will modify this equation and we will find, suppose instead of this x e raised to power x, I will write here, suppose note, my x is 2 raised to power x. My x is 2 raised to power x, then we can write here this as e raised to power 2 into log x. You can write e raised to power 2 into log x. Here this is x square. You can write e raised to power, sorry, here we can write this as x into log 2. Just put here, I will do this e raised to power x into log 2 we can write. I will go through proof also how we can write here. Right here x is equal to 2 raised to power x. If we are taking log on both side, this log x is equal to x into log 2, and if we are raising this power as e raised to power log x is equal to e raised to power x into log 2. Again, e raised to power log x is nothing but x, this capital X is equal to e raised to power x into log 2, and therefore I will write here this x as 2 raised to x is nothing but e raised to x into log 2. Now if suppose our right hand side is 2 raised to power x, then we can write pi as 1 upon f of d into 2 raised to power x. 2, or this is any constant. I will write this constant randomly. I will write here a raised to power x, and its pi is 1 upon f of this, we can write 1 upon f of d a raised to power x, we can write in this way e raised to power x into log 2. Now this is our constant, this part is our constant, and here we can replace this by a. This is just like e raised to power x. Now a is here, This is our log 2 or log a. Right here, this is log a into e raised to power x into log 2. But again, e raised to power x into log 2, we can write here 2 raised to power x or a raised to power x. In this way, we can write here our pi. Okay, again, when we'll solve problem, we'll get this idea clearly. I will take here example on this. We'll find pi. Find pi. Suppose our differential equation is d square plus 2d plus 3 into y is equal to e raised to power 2x. Here pi equal to 1 upon f of d. F of d means d square plus 2d plus 3 into e raised to power 2x. Again, right hand side is e raised to power 2x. This is our constant a. Now we have to replace this d by constant a. Means here 2 square plus 2 into 2 plus 3. This is into e raised to power 2x, which is equal to 1 upon 4 plus 3. This is 4 plus 4, 8 plus 3. This is 11 e raised to power 2x. Means pi equal to 1 upon 11 into e raised to 2x. In this way, we can find out our pi. I will take another example. Suppose we have to find out pi for d square plus 3d plus 1 into y is equal to 3 raised to power x. Here, if we have to find out pi, d square plus 3d plus 1 into 3 raised to power x, as usual, d square plus 3d plus 1 into, I will write here 3 raised to power x as e raised to power x into log 3. Now this is our constant log 3. Now we have to replace this as log 3 whole square plus 3 into log 3 plus 1 into e raised to power x into log 3. Again, e raised to power x into log 3 is 3 raised to x. We will write 3 raised to, this is 3 raised to power x. And this is our pi. Again, I will take here another example. This is d2y by dx2 minus 1 minus y is equal to e raised to power x. Here, this equation we can write d square minus 1 into y equal to e raised to x. It's pi 1 upon d square minus 1 into e raised to x. This is as per our formula. Here, if I will try to, what is value of a? A is equal to 1 here. This is constant a. If I will put here a, then this becomes 1 square minus 1 and this total denominator becomes 0. If denominator becomes 0, then we have this method to find out pi. If denominator, here this part, f of a, means this f of a. This f of a is 0, then we have to go through this part. And then we can write x into its derivative. Again, I will use this property here. If I am putting a here, this becomes 0. Therefore, we have to write x into 1 upon its derivative. What is derivative of this? D square minus 1. Its derivative of d square is 2d. This derivative is 0, e raised to x. Now, this is our simple term. Now, I will put a is equal to, this a equal to 1 in this formula. This is x divided by 2, 1 upon 1 into e raised to x. And we are getting this is 1 by 2 into x into e raised to x. This is your pi. Means if denominator becomes 0, then we can write its derivative and successively we can write our pi. Again, I will take one more example. Suppose d minus 3 raised to power 3 into y equal to e raised to minus x. Again here, to find out pi, I will write here this is 3x. 1 upon d minus 1 cube, d minus 3 cube into e raised to 3x. Now our method is that we have to replace this d by this 3 and this becomes 3 minus 3 becomes 0. Therefore, we have to write x into 1 upon its derivative is 3 into d minus 3 square into e raised to 3x. Again, I will put this 3 here, then this becomes here. Sorry, here is 3. This 3 here, this becomes again 0. Then we have to write this is x square. I will write this 3 here into 1 divided by its derivative is 2 into d minus 3 into e raised to 3x. Then this is equal to x square divided by 6. Again, if we are putting 3 here, this becomes 0. Then again I will write here x cube divided by this 6, 1 upon its derivative is 1 into e raised to 3x. Then total we are getting x cube divided by 6 into e raised to 3x. Its denominator becomes 0. Then we can write here successive. We are taking here x multiplied by x and we are taking successive derivative of denominator till we will get this number as non-zero. In this way you can find out pi if our right hand side function is e raised to x. Again I will take here one more example depending on this. Suppose our differential equation d square plus d plus 5 into y equal to 4. Now right hand side is 4 only. This is not in terms of e raised to function. Still this problem is there, this is constant. Then we can write here problem under this method. This is 4. Shall I write this 4 into e raised to 0x? Yes, we can write 4 into 0x. This is constant 4, we can take outside. This is 1 divided by 0 plus 5. Because d we have to replace by a is 0 into e raised to 0x. And we are getting this is 5, that means 4 by 5 into e raised to x is 0. Where e raised to 0x is 1. And we are getting this is our pi if our right hand side is constant term. If constant term, then we can write here directly this in terms of e raised to power function. Now second method is here. If our x means right hand side function is sine of ax or cos of ax, means our differential equation is in this way: f of d into y is equal to x, and if our right hand side is sin x or cos x, then we can write usually our function as d square into f of d square into y equal to x. This x is our sine function or cos function. In this case our pi is 1 upon f of d square. We will take sin x or cos x, both having same result. This should be d square, keep in mind this should be d square, and here we have to write our pi as f of minus a square into sine of x, or same formula works for cos. F of minus a square sine of x. Again this denominator is not equal to 0. If suppose this denominator is 0, then again we can write here 1 upon its derivative minus a square sine of x, and again we are checking this should be not equal to 0. Suppose again suppose this is equal to 0, f dash of minus a square is 0, then we can write x square into 1 upon f double dash of minus a square into sine of x. F double dash of minus a square is not equal to 0. Means if our this depending on is not equal to 0, then yes. If again this is 0, then we can write x cube into its third derivative e raised to third derivative sine of ax. Same formula works for cos. Therefore I am not giving formula for cos. Same term, instead of sine we can write here cos. Same formula works for this cos function also. How we are solving problems on this? Here example, I will write our differential equation in this way. Suppose my example is here we have to find pi. D square minus 5 into y is equal to cos of 2x. This is our problem and we have to find out pi for this. Pi equal to, as per our formula 1 upon d square minus 5 into cos of 2x. This is our pi. Our rule tells that, this is our rule tells that we have to replace this d square term by a. I am replacing only. Again keep in mind, in our this function f of d, we have to replace d square terms or powers of two term, d raised to power 2. This term we have to replace by minus a square. Now here this is your d square. I will replace by d square as minus sign. D I am replacing by this 2 and square of this minus 5 into cos of 2x. This is equal to 1 upon, this is minus 9 total into cos of 2x. This is minus 1 by 9 cos of 2x. This is our pi by using shortcut method. Again this is very easy method, and usually we can find CF by using this shortcut method. Now here our example is in this way. Suppose we have to find pi for 1 upon d plus 1 into sine of 3x. Now here we will not find pi for this, because we should have square term. This square term should be there. Therefore I will rearrange this term d minus 1, and here I will multiply and divide by d minus 1. Then we can write d square minus 1 into sine of 3x. Now we can replace d minus 1 divided by this d square. I will replace by 3, moreover minus, and square of this 3 is 9 minus 1. This is sine of 3x, which is equal, this become total minus 1 by 10 into d minus 1 into sine of 3x. This is equal to minus 1 by 10. I will operate this operator on the sine function. This is d into sine of 3x minus sine of 3x, which is equal to minus 1 by 10 d means derivative of the sine function, and derivative of this sine function is cos of 3x into 3 minus this sine of 3x, and this is your pi. I will write this pi in this way also. This is minus 3 divided by 10 cos of 3x plus 1 by 10 into sine of 3x. This is our pi for our given problem. This is our pi for sine of 1 upon d minus 1 sine of 3x. Okay. Again here I will take this simple example of this. So suppose we have to find out pi for 1 upon d square minus 4 sine of 2x. Again here what will happen? To find out pi for this, we have to replace d square by this 2. Sorry, here I will take plus. This we have to replace d square by minus a square. Means here if we are replacing this, I will take minus sign, and square of this a means 4. This becomes 0. Means here minus d square is 2 square plus 4, and we are getting this is equal to 0. Therefore again here if this is 0, denominator 0, then we have to take x into 1 upon derivative of this function, and derivative of this function is 2d into sine of 2x, which is equal to x divided by 2. Now here this d means d by dx, then 1 by d means integration of this function with respect to dx. Keep in mind 1 by d means integration. Therefore we have to find here integration of this function, sine function. We are getting this is minus cos of 2x divided by 2, which is equal to x divided by 2, or I will write here minus x divided by 4 into cos of 2x. This is our pi. Okay, thank you. We will discuss for remaining method in coming lecture. Okay, thank you.